Hello, everybody. Welcome to Conics 5, fifth class on Conics, the last class on Conics. And today we're going to be covering what it calls applied problems, but most of you would call those word problems. Basically, you're given a bunch of words with numbers in them, and you need to convert them into something that we've seen in this unit. So into either a parabola, circle, ellipse, or a hyperbola. I don't think there's a hyperbola question in this section. I'm not sure why, but I don't think there is. Can I just get a general idea? Did anyone watch Tom's video? I don't know if he ever watches videos, even though I could ask anything there from the test, But just so I can get a sense of whether or not I should maybe go back over the beginning ones. Maybe it's safe to just assume you didn't watch it. You did watch the video. Rania, I think, said yes. I'll just pick and choose which ones I go through today. I want to be very clear. You got to watch the videos at some point, because some of the examples that I don't do could be types of examples that would be covered on an assignment or a test. Just going to mention that. I avoid them to some extent as much as I can, but things fall through the cracks sometimes because you are expected to keep up with them. So make sure that you are giving it a shot, okay? Yeah, I understand that the time is short. I'm just saying that's the expectation. I'll do everything that I can to get you through without having to watch those videos. But that is the other section of the course. So just try not to forget about it. And if you are practicing, that is good because, of course, the practice is. Anyway, I just wanted to mention that the videos are there. The expectations of the course, whether or not you feel like you have the time to do it or not, you just have to manage your time accordingly. Okay. So let's start on applied problems here. Let's just do the first one because it sets us up for success, I think. Actually, the first one is similar to the third one. Let me see here. Yeah, I'll do the first one. It was done on the video, but that's okay. So this is page 37. So in this question, it says, the swords that cross over Grand Hamid Street approximate a parabola. So what it means is that over the street here, this is essentially a parabola. We could draw a parabola on top of it, and it would be kind of okay. It would match. It says, if the base of the arch is 65 meters wide, so let me just draw a base here. Let me make it more clear. This base, that distance, 65 meters, and the maximum height is 35 meters. So the top point there will be 35 meters. Formulate or make an equation to give the height at any point along the arch. So really what that means is find the equation of this parabola. So before we can do that, we sort of need to get our important pieces, right? In order to make a parabola, you need a vertex and you need the p-value. And really, that's kind of all you need. H and K, of course, is the vertex, and then the p-value is where the focal point would be, where the focus is. So I'm just going to draw a sketch over here. This parabola on the right side of the screen now, I've got some important information. I'm going to approximate this. So let me draw the parabola like this. Okay, that's my parabola. I'm going to mark the points that I think are important. And you might notice here, I drew a line through the center. I made the origin at the center. That just makes it symmetrical so that my math will work out as nice as possible. You could put the cross anywhere you want, but it always makes the most sense to go right down the middle. And don't cross through the vertex, just cross it the way that I've done here. Okay, now we could label the points that we know. So for example, if we know that this is 35 meters high, then that's a really good indication that this point up here is 0 and then up 35. Okay, so we have a point, we have the vertex. In fact, I could write right here that that's the vertex. On either side, on the left and the right, we actually know what those points are because, and let me try to get a good color here. we know that this whole length is 65. So if that whole length is 65, then divide it by 2 and split it up on both sides. So this distance here would be, what's 65 divided by 2? I think it's 32.5, but yeah, 32.5. So that distance is 32.5. This distance is 32.5. So we know our points, those 2 points on either side. That point here, let me color code it actually. This point here is 32.5 and 0. I see your question, Tarek. I'll answer it in a second. And this point here, negative 32.5 and 0. So your question was, if the picture wasn't there, how do we know which way it does open? Well, sometimes you actually don't need to even know that information. You don't need to know the shape, because when you solve this, when you put in the important points, you're going to get your p-value out of it. So I guess to give you an idea of what we're going to do, the first thing is we're going to do is get the vertex. The second thing we're going to do is find the p-value using a point on the graph. So it'll give us the p-value. It's going to throw out a negative for us, and it'll tell us that it's going down. So you sort of don't need to know ahead of time. But let me give you another example. I'm just going to scroll forward a little bit so you can see an example. For example, in question 3, I'm not going to do it, but the entrance to a building is a parabolic arch. Well, if it's the entrance to a building, of course it's going to be one downward, okay? So we got the full picture there. If I was to look on the next one, a tunnel is built in the shape of parabola. A tunnel is, of course, going to curve like this. So most real world structures that involve parabolas are going to be curving down anyways, because you usually walk through them. You know what I mean? You can't have an arch that goes straight up into the sky forever. It doesn't make any sense. Okay? So most times in real life, they're going to be curving down. Is that okay for you? I assume that it's okay. I feel pretty good about that explanation. Okay, so I said here, I gave you 2 steps really. You got to get the vertex, and then you need to find P. And the reason we're finding P is because first of all, what form is this? Well, this is a x squared form parabola. And we know that it should have a negative p-value, but we don't necessarily need to know that ahead of time. So I'll just remove it for now. X squared form has this shape. This is the equation for it. I minus k. And I'm actually going to keep this 4p. I'm not going to put down plus or minus, because the p-value that comes out of it will tell me if it's positive or minus, okay? So this is the equation I'm trying to match. So just watch this. Put in everything you know. Well, do we know an x value? Do we know an x value here? Well, we definitely know an x value. We know 3 different x values. We know this, and we know this. Now the vertex x value we're already going to use, it's h. So in order to substitute this into the equation to find p, we need to choose either this x or this x. And it doesn't matter which one, but which one would you suggest that I substitute in? $32.5. And I'm gonna go ahead and try to read your mind here and say it's positive. So why not choose the positive one? Because positive is usually easier. So I'm assuming that's why you would choose that. I'll go ahead and put that in. So I'm gonna put in 32.5. I'm just putting in, let me make this super clear, okay? We're gonna sub in a point, in this case 32.5 and 0. And that's going to be for x and y. Okay? Sorry, I'm just trying to get all my thoughts straight about how I want to show this. Okay. First things first, we needed the vertex, we got the vertex, and now we're trying to find p. So if we have p, we have the whole thing. So let's sub in what we know. We're going to sub in an x value. We know h, so minus 0. That's h squared equals 4p. I'm going to keep 4p general. I'm not going to split them up, treat it like one variable. And then what's our y value? Our y value is 0. minus k, and k is 35. So let me just color code this in case you're not sure where I got everything. This is my h, this is my k, and then of course the other values are the purple ones. That's just a point from the graph. So we just rearrange this until we can solve it. So on the left side here, 32.5 all squared. 32.5 squared is 1056.25 equals 4p. Keep 4p general. There's no reason to split it up because it's 4p in our equation here, yeah? You don't need to solve for it. What's 35? 0 minus 35 is, of course, negative 35. So just divide both sides by this. And we'll get our 4p. So 1056 divided by 35 gives us negative 30.2. Okay? So I'm going to put that in a box because it's very important. Let me put in the two things that are most important, the vertex and the p-value. That's all we need to describe a parabola. So let me recap. We have a curve. We're given very important information about the curve. We are given the height and the width. The height gives us the vertex. The width will give us some x values that we can use, or x and y values, some coordinates. Two of them, actually. We're going to just take that information, throw it into the parabola equation, and solve for the missing piece, which is p. If we have p, or 4p in this case, we have it. And then Tara, just to cap this off, I told you that he was going to give us a negative, and it did. Okay, so we have everything that we need. All we need to do now is actually write the final form. Let me just make this a little smaller here. And what do we have? Final equation, x squared equals negative 30.2 y minus 35. It's our final equation. You could give that as a fraction too, but it's fine the way it is. Decimals are not a big deal for this. So anything I can recap on this? We're going to do maybe 2 or 3 of these style today, and you should get really good at them. No questions? We're all still waking up?
No, sitting good.
Okay, nice to hear from you, Nasser. So let's see here. I'm just going to quickly sketch it in Desmos. And again, I'm not going to stop saying this. If you're not sketching things in Desmos, you're missing a huge opportunity to check all your work. Why would you not? Why would you not use Desmos? I don't understand. So that's just my spiel. You know, even for the assignment, check your work. I'm going to put in my final answer. Y minus 35. Where is it? Where is it? Oh, there it is. That looks like an arch. That looks good. What's this number? Woo! 32.5. Close enough. I rounded my decimal, so of course it comes out rounded. And then my vertex 0.35. That's the curve. So my final answer, my final equation gave me back the information that I started with. Of course it's the right answer. It's got to be. I don't even need an answer key or anything to tell me that that's right. Now, if it was wrong, you would go back and see if there's something wrong with your information. Okay, so hopefully that is making some sense to you. If not, we'll try to keep doing some questions. All right, I'm going to try 2. Actually, 2 was done by Tom. It's a little bit of a longer question, and he did a pretty good job of working this out. Let me see here. Yeah, I think I'll just leave it. I'll leave this one. He did it in the video. You can just jump to that. That's fine. I'm going to do another question like the one we just did to see if you can do it. Actually, in fact, I'm going to give you a few minutes for you to try it because it's so similar to the previous question. This is really good practice. These are, you know, this would be a nice difficulty question for something like a test. Okay, so I'll read the question, then we'll do it together. The entrance to a building is parabolic arch, 5.6 meters high at the center, at the center. So put your vertex with a line through the center, and then 7.4 meters wide at the base. And you're really finding the equation that represents the arch. Okay, so I'll just draw a quick picture for you. I'm going to draw my axes, of course, and I'm going to draw a quick parabola. That's my arch. Of course, the arch would be down like this because you need to be able to walk through it. This is a real life entranceway. And let's write down the information that we have. 5.6 meters high is trying to tell you that your vertex is 5.6 meters off the ground. So we've set it at the center, and we're saying it's 5.6 meters high. The 7.4 meters wide at the base is telling us, of course, how wide it is. So that means the base, here, let me try to make it clear. This whole base here is 7.4. So half the base is 7.4 divided by 2. So I'll just go ahead and calculate it with you. 3.7. This is also 3.7. So just label that on your graph. 1 point, that's over 3.7 from the center and 0. It doesn't have a y value. And then on the left side, we'll put, once again, I'll erase that, negative 3.7 and 0. You don't need both of those. In fact, only one of them would be what's really important here. And just in case you missed that, this whole distance here, if you need it, that's 7.4. That's why half of it is 3.7 on either side. Okay, so that's everything you need. Again, I'll write down for the parabola, really all you needed was the vertex. And then you need to find P, or more importantly, find 4P. Okay, so take maybe 2 minutes and try to solve that. It really doesn't take much effort now. These are fast questions, but really good for a test or even an assignment. But your assignment won't have this stuff on it today, so I guess just the test. Okay, take 2 minutes. So if anyone gets the final answer, please let me know. Thankfully, it's pretty fast. I'll give you a hint in case you're stuck. We're going to substitute in the point 3.7 and 0. What's my x? 3.7. I'll slowly do this with you. Oops, this is not even the right formula. Never done that before. Minus h, minus 0. Square it. 4p is what we're looking for. Y, what's my y value? 5.6. No. My y value is 0. Trying to keep my colors consistent so you can follow. And then 5.6 is my y value of the vertex. Okay, once you have that equation worked out, there's very little to do except for some algebra. So then 3.7 squared, I'll just write this out all in one bit. 4p is 3.7 squared divided by negative 5.6. What is that? Anyone get it? What do we have for the answer? Dun, 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 dun. I think some people are studying. Studying for your assignment. Okay, let's see. 3.7 squared divided by 5.6. Yeah, 2.4, 2.44. And as Tarek asked about earlier, you have a negative there. It comes out. It comes right out of this process. So even if you didn't have the sketch, it would be very hard to do this without the sketch, but you could do it. It comes out of the answer. So final answer here. X minus h. So again, h is 0. So x squared equals negative 2.44. That's my 4p. Y minus k, so y minus 5.6. Final answer. Thank you very much. Okay, so that's what we have. I'll keep that there, and I want to graph it on Desmos just to check it because it's silly not to. And it's so easy to use Desmos. So check my work here. Goodbye. X squared equals negative 2.44, y minus 5.6. Let's just zoom in on this. Okay, it looks good. Let's make sure that the information on it is correct. So 0 and 5.6, perfect. 3.7 and 0, close enough. Negative 3.7 and 0, good. This is exactly what I wanted. So, excellent. Just as a connection to real life here, more and more, now that computers are just, you're carrying around supercomputers in your pocket every day, now that computers are so ubiquitous, they're everywhere, architects and engineers are using them to model more and more buildings. So for example, even the buildings around here, like the newest museum that was opened, all of that was modeled with a computer. So it was all modeled based on curves that were given by a computer. And then we took that and made it into reality, not the other way around. It used to be that you'd do this stuff by hand and make it, but now there's computers that make the design for you, or at least help you make it. My point is, equations like this, equations like the one that we just found, are really powerful because they can tell you the height at any point along this curve. If you see a curve and you know the height, you know the maximum height, that's the only thing you really know, and you know the width, you could put in any x value into this equation now, and it will give you the height. Like if you wanted to go halfway over on the curve, what's the height? All you need to do is just put in a number. It can tell you the entire description of the curve, no matter how complicated. So when you have the equation of this curve or a building or whatever, you can do a lot with it. And in fact, Doha is one of the premier places in the entire world for cool buildings. And I'm sure you know this. The Middle East in general has some of the coolest buildings that exist on the earth. And they're all modeled with computers. So just something to keep in mind. Now, they're not all modeled with computers only. Of course, you have an artist and an artistic vision who then will help use a computer to help him. But anyway, I just thought it was cool. Today we're just doing parabolas, so just didn't mean to get on a tangent there. Okay, so are we all good with this? I'm going to move on to the next few questions. I want to do a different type of question before we actually do the assignment. 4 was done by Tom, I think. So let's see, 4 was done by Tom. He did a fine job introducing that. 5, I would like you to try, okay? I'm going to give you maybe, well, I gave you time to do it last time and no one gave me any answers. So I'll just do one quickly for you, okay? I know there's a lot going on in your brain right now. Maybe I shouldn't ask you to do too much with the assignment coming up. So I'll just help you through this. I'll talk you through it. So we have a tunnel built in the shape of parabola. The maximum height will be 13 meters. So this here at the top is at 0, 13. That's our vertex. And the maximum width is to be 12. That means that the points on either side are half of that each. So let's just be very clear. I'm going to draw down through the center. And on either side is 12 divided by 2. So 6, 0, negative 6, 0. And that should hopefully make sense why this could be a 4-meter distance here. The vertical clearance, sorry, what is the vertical clearance? The height of the tunnel, 4 meters from the bottom edge. So it's saying, what is this point? It's saying, find this point. Tell me what the coordinates are. So that's going along with what I said before. So really, this is just a three-step question. The first two steps are exactly the same as what we did before. First step is know the vertex, which we already know. Second step is find 4p, because that describes the curve. And then 3, find y when x equals this is a 2-meter distance. So find y when x equals 2 meters. Okay. We'll worry about that third step after. Let's go through this. First things first, we need to use our equation. This is a x squared form. So it's going to look like this. I ignored the value next to the x because it's centered at 0. Sub in my values, okay? Substitute in a point. Which point am I going to use? That's something I'll ask you, just so we're all clear here. Which point am I going to put into this equation now? It's quiet out there today. Are you all still with me? 6 and 0. Thank you, Mohammed. 6 and 0. You could use -6 and 0. It would just be slightly more difficult. Okay, so I'll put 6. I'm going to square that. I'm solving for 4p because that describes the curve for me. Y is 0, and my k is 13. Okay, now let's just go ahead and solve for that 4p. 4p must be 36 over -13. Or in other words, 4p is, what's 36 over -13? I mean, let's just keep it like that. Let's just keep it like that. There's nothing wrong with keeping the fraction. I haven't kept a fraction yet, so maybe it's not such a bad thing to just show you that you can keep it. I usually like to keep it anyways. So then our equation, therefore, ... the equation is this. So that's my equation, but that's not finished. This question's not finished. And hopefully you can see these questions are actually fast once you know like the trick, which is vertex find 4p. The third step, so I did the first step vertex, second step get 4p. Third step, find y when x is 2. So what I mean by that is, like, just follow me here. If I was to start at the center and go over by 2, you need to tell me what value does it pop out when I put in that x value. So just treat it like a function. Put x into my equation and get the y back. And so that's what I'm going to do. Slowly erasing my diagram. You can try it yourself too. Okay, what am I going to do now? I'm going to sub in. I'll use red. I need to substitute in x equals 2, because that's what I care about. So 2 squared, I don't need the brackets. 2 squared equals -36 over 13, y minus 13. How do I solve that? There are different ways to approach this. I'm not sure what your preferred way to do this is. Does anyone have a way that they would choose to solve this? There's many ways to do it. What do you think? How am I going to get to that y? Square root of 2. Well, I'm definitely going to square root of 2. That'll be a 4. So let's just go ahead and put it over here. That'll give me 4 equals -36 over 13, y minus 13. Let me just make that into a decimal. Now that I'm ahead of myself here, I'll just convert that to a decimal. The way that I like to do this is to expand it first and then rearrange things. But it depends on who you are, how you prefer to do this. Actually, scratch that. I'm going to divide both sides by this. So I'm going to divide both sides by this. So it's probably a little easier. 4 divided by that is negative 1.44. This gives me y minus 13. And if you solve that for y, you end up getting this. (11.6 meters). Okay, there are many ways to solve that. Sorry, I sort of ran out of space. I'm going to fix the spacing while you get that copied down. When you look back on this later, it'll be nice to have it all vertically. I didn't manage to do what I wanted to do here. Oh my goodness. Sometimes I wonder why my brain works the way that it does. Anyone ever feel that way? Why does my brain do this to me? Okay. I didn't help anything. Sorry about that. So Sada, you said we multiply. Yeah, it's up to you how you want to do it. You could multiply by the fraction. You could do an expansion, blah, blah, blah. What's important is that you get that y value in the end. So that's the biggest part. Okay, so any questions on this before I do a question that's not a parabola? Because I'm kind of getting bored by all these parabolas here. Are you okay? Are you alive out there? I'm gonna take that as a yes. Beautiful silence. I'll move on. If you need me to go back, tell me. This one I was thinking I might do, but you could just do this one for homework. It's almost identical to what we did before. In fact, it's pretty much exactly the same. The only difference is that you're going to end up with a positive p instead of a negative p. It's the only difference. Everything else is the same. This one is a parabola. It's a slightly different question. Let's try it. So the primary mirror in a telescope is a parabolic, so parabola cross-section, as shown in the figure below. What is the focal length, vertex to focus, of the mirror? Okay. Interesting. Anyone have any idea what I'm asking? These are questions that you could totally expect on the test. Things like asking you to understand what it means to have a focal length. Or in other words, it says, what is that distance? Anyone have any ideas? You can describe it as one letter. The foci. Yeah, F is the foci. What's the distance from the vertex to the foci? What is that in terms of what we know? C. It's C for ellipses and things. For parabolas, it's called P, but it has it's the same idea. It's P. A, C, A, B. Ah! Now vertices, and for parabolas, we have two things. We have vertex, and we have 4P or P. Those are really the only things that we have. And of course, the directrix is from that. But these are the important things that we need to worry about. So we just need to find P, in other words. So let me show you what we have here. We have, from the center, we have a distance of 1.2 and 1.2 to these points. So these points, just to be clear here, this top point would be 0.00625, and it would be up 1.20. This would be negative 0. Oops. This would be, well, we don't need to worry about the bottom one. It hasn't given us that. So I'll just erase what's going on here. So you'll notice it's the same as what we've been doing. Let me just try to make this clear. First of all, what type of section is this? I guess I should write the vertex. what type of parabola is it? Is it y squared or x squared?
It's y squared.
Y squared, good. And we know the p is going to be positive, but this is y squared form. We know that because it looks like this. All right, and the p is going to come out positive. We know that ahead of time, but the math will give us that. So y squared form parabolas look like this. And in this case, because we don't need 4p anymore, we need p, we're just looking for that p value. That is the distance from the vertex to the focus. That is the focal length. It even says that. Vertex to focus, that is the distance. We just need to find p. So let's put in everything we know. Let's see here, what do we know? We know a y value, we know h and k, we know our x. So we're going to substitute in 0.00625 and 1.20. Hopefully you're seeing a pattern here. This gives us y squared on the left. Oops. This gives us 1.20 squared on the left. For p, our x value is 0, so really it's just the h value that we care about. Sorry, no. Our x value is 0.00625. Sorry, I'm getting all these numbers mixed up because I'm staring at them, and I'm sure you'll find the same thing. And the h is 0. Okay, just to color code this, the vertex, this is that. This is that. So if you match those up in the equation, that's why I'm getting what I'm getting. And if you solve this for p, you get 57.6 meters. So that's the answer. P is the distance from the vertex to the focus. That would be our fully written answer. So again, if you want to know what the focus does, it's if you shine light in on this, the light will bounce back and it'll all focus in on that one point. It's kind of how your eye works too, but I won't get into that. Long story short, focal length means find P. And the way we found P is exactly what we've been doing. We use our general form or our standard form for the equation, put in your vertex, put in an x and y value, solve for the missing piece. All right, so I'm going to do just one more question because I want to do at least an ellipse today. And the other ones were done by Tom in the videos. Okay, so you got lots of time to watch them if you want to catch up on those. But is there anything I can clarify for this question?
Everything clear.
Good, Nasser. Good. One more. 8 is another parabola, very similar to what we did before. Again, the full solutions to this are online, so you can see it and go, oh yeah, okay, same thing. 9 is a slightly different question, but it's actually very simple. Even though it's an ellipse, it's very simple. So let's just read it. The vertical cross-section of a culvert under a road is elliptical. Don't worry about what culvert means. We're dealing with an elliptical. The culvert is 18 meters wide and 12 meters high. So what I have, if I had something 18 wide, 12 high, it would look like this. And if I was to draw my axes, it would be like that. And then I know, well, if I know that this is, let me color code it. This distance is 18 meters. This distance is 12 meters. I know a lot of special points on this. Maybe I need them, maybe I don't. Let's see. Find an equation to represent the perimeter of the culvert. Find an equation of the ellipse. Okay? And with the origin at the road level, which is 2 meters above the top of the culvert. This is unimportant information. Sorry. Okay, so an ellipse. First of all, our vertex, sorry, our center is at the center at 0, 0. So let me write out the equation of what it is. X squared over something, y squared over something equals 1. Now, all you need to do is tell me what is A and what is B. Does anyone know? Well, A is the distance
18
from,
is A.
say again?
18 is A.
That's 2A.
9 to it.
Yeah, half of it. 9, 9.
So 2A here is 18, which means that A must be 9, because 2A is the length of the major axis, so it must be 9. And then B, well, I'll give you one more chance. What's B going to be? B is going to be 6, yeah. B is 6. That's because 2B is the length of the minor axis, 12. B is going to be 6. Okay, so now we actually have all of our information. We just square them, put them in the equation, and we're done. So 9 squared is 81. It stretches in the x direction, so that's where it goes. And 6 squared is 36. Done. For those of you that are wondering where these came from, this is a squared. This is b squared. Okay, so that's a nice short question, but if you need to understand the parts of the ellipse, it has a little bit of everything. You need to know what the center is. In this case, 0, 0. We'll always make it 0, 0. You need to know what the major axis means. It's the longest axis, and it goes under the one with the that matches that direction that it's stretched in. So it goes under the x. You need to know that the major axis is 2a, so a must be that divided by 2, and then the minor axis is 2b. So lots of information into the one little pile, but this is actually a very straightforward question if you understand what's going on. I guess I could say that for any question, but especially this one. Good difficulty. All right, so that's it for today's class. The rest of the things here are all things that Tom has done. I've actually done some that Tom already did. I'll stop the recording here. So bye-bye, everybody. Have a great day. And